All right, so the first thing we want to talk about is long division. So before we start talking about long division for polynomials, let's remind ourselves how long division works for integers. So say we wish to divide 3 into 107. We would start off by asking, well, how many times does 3 go into 10, which is 3 times. So 3 times 3 would give us 9. We put our 9 down here, and then we would subtract. So then 10 take away 9 is 1, and then we bring down our next digit, and we rinse and repeat. So then how many times does 3 go into 17, which is 5 times. So 5 times 3 is 15. And we subtract, and that gives us 2. And then 3 can no longer divide into 2, so then we would say we have a remainder of 2. Well, then this would tell us that 107 divided by 3 is the same as, we have 35 wholes, plus we have our remainder, which is 2 over our divisor. So then that would tell us that 107 over 3, if we throw out this part right here, 107 over 3 is about 35. That would be an approximation of what that is. It's about 35, and then we have a remainder of 2/3. So 35 isn't a perfect approximation, but it does at least give us an idea of what it looks like. All right, well now our real goal is to expand this to polynomials. So the good news about this is that polynomials are the same type of object in mathematics as integers. The reason that this is important is everything that you've ever learned about the integers still works for polynomials because they're the same thing. So for instance, if we were asked to divide x minus 3 into the quadratic x squared plus 5x take away 2, we're going to start off by doing the exact same thing. But we need to ask ourselves the question, well, how many times does x divide into x squared, which was the same thing we had up here, how many times does 3 divide into 10? So our question was, well, how many times does x divide into x squared? Or in other words, what is x squared divided by x? Well, x squared divided by x is just x. That's actually not the best way to think about this. When we're doing polynomial long division, the better question to ask ourselves is, well, what would I multiply x by in order to get x squared? Well, that would be x times x gives me x squared, so I put my x up here. Then, after we have our number up here, what did we do? We went 3 times 3 is 9, and we put it down here. So we're going to do the same thing. What's x times x minus 3? So we distribute our x into the x minus 3, so x times x gives us x squared, and x times negative 3 gives us negative 3x. So after we did 3 times 3 equals 9, what we did next is we subtracted, right? So we're going to subtract this whole thing. So we put it in parentheses and subtract. So x squared minus x squared, well, they reduce out as they should. And then here is where we have to be just a little bit more careful. So there are lots and lots of minus signs. So notice I have minus a minus 3x. So what does minus minus give us? Plus positive. So I have 5x minus a minus 3x, which is really 5x plus 3x is going to give me 8x. So after I subtracted, what do? You bring down the next thing. And then we rinse and repeat. So then, how many times does x go into 8x? Well, what times x gives me 8x? Well, that would be positive 8. So then 8 times x is 8x. And 8 times negative 3 is negative 24. And then I subtract. The 8x's reduce out as they should. And then I have negative 2 minus a minus 24, so that's plus 24. So negative 2 plus 24 is going to give me 22. So now x no longer goes into 22, so that's going to be my remainder, just like what we had up here. So then this would tell me that x squared plus 5x minus 2 divided by x minus 3 is equal to, my whole part is x plus 8 plus my remainder, which is 22, over my divisor, which is x minus 3. So for our u-try, we ask ourselves, well, how many times does x go into x squared? Or said another way, what times x gives us x squared? So x times x gives us x squared. So we have x, and x times x is x squared. And then x times negative 2 is negative 2x. And then we subtract that entire binomial. The x squareds reduce out, and then we have to be a little careful because now we have minus a minus 2x, so that's really plus 2x. So 5x plus 2x gives us 7x, and then we bring down our 2. So then our question is now, well, what times x gives us 7x? So that's 7. So we have plus 7. 7 times x is 7x. And 7 times negative 2 is negative 14. But once again, we have to subtract that entire group. So our 7x's reduce out as we would expect. But once again, minus a minus makes it plus. So negative 2 plus 14 gives us 12. So x no longer goes into 12, so that's going to become our remainder. And we end up with our x squared plus 5x minus 2 all over x minus 2 is x plus 7 plus our remainder of 12 over our divisor of x minus 2. All right, so one thing we do have to take note of with polynomial long division is the following. If a polynomial is missing any terms, we must fill in any missing monomials with 0x to the n. So what I mean by that is the following. So for example, if we had x squared take away 9 is missing the x term because it has a degree 2 and it has a constant which is degree 0, but it's missing its degree 1 term. So it has to have all of them as we count down. So we would rewrite this as x squared plus 0x take away 9. So notice that didn't change this because what's 0 times anything? 0. And if you add 0 to something, does it change? No. So x squared plus 0x minus 9 is really the same thing as x squared minus 9. So if we were asked to do the division, x squared minus 9 is divided by x minus 4, the first step is that we would replace this with this. So when we set up our division, we would have x minus 4 divided into x squared, our filled in missing term, which is 0x, take away 9. So now when we do our division, it's going to work exactly like we did up here. So what times x gives me x squared? Well, that's x. X times x is x squared. And x times negative 4 is negative 4x. We then subtract, and our x squareds reduce out. And then minus a minus 4x makes it positive. So 0x plus 4x gives me 4x. And then I bring down my 9. So it's worth noting at this point, if we didn't fill in that missing term, we would have ran into a problem because our columns wouldn't have lined up, and negative 9 and negative 4x aren't like terms. So really what this is doing when we fill those in is it keeps our columns organized so that all of our like terms end up where they're supposed to. So we continue to rinse and repeat. So what times x gives us 4x? Well, that's 4. We have 4 times x is 4x, and 4 times negative 4 is negative 16. We then subtract once again. Our 4x's are going to reduce out, as they should, and then 9, or negative 9, minus a minus 16, so negative 9 plus 16 is going to give us 7. So we end up with our remainder of 7. So finally, at the end of this, x squared minus 9 divided by x minus 4 is equal to x plus 4 plus 7 over x minus 4. So that would be our division and our remainder. So we have our whole part is x plus 4, and our remainder is 7 over x minus 4. All right. So that ends our sidebar.